Assalamualaikum warahmatullahi wabarakatuh. My name is Intan Analesti. I'm from 6B class, and in this occasion, I will explain to you my material. The title is Sample Location Problems. Sample location problems. In geographical and related research, uncertainty and error have arisen in the selection, application, and interpretation of designs in plane sampling largely through a failure to differentiate between area sampling and location sampling procedures. A survey of some commonly used area sampling designs indicates the frequency and extent of this error. Location sampling has remained a purely understood technique through its confusion with area sampling, and there has been a consequent failure to grapple with the problems of stratifying by location when the primary sampling items are of varying areal extent or are irregularly spaced. An objective method of stratifying by location employing minimal aggregation is described and is used as a basis for both systematic and random samples. Tests on locationally stratified from sample designs based upon certain known and hypothetical form characteristic in one new suit well sire indicate the increases in sampling precision obtained through locational stratification are directly related to the levels of spatial segregation in the items being sampled. Measures of centrality, or sometimes called location parameters. The title of this chapter indicates an interest in a location parameter of a single population. More specifically, we assume that x1 blah 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 xn, not negacy p, are independently and identically distributed. We observe a random sample, not negacy x, is quantity x1 blah 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 xn close quantity, and we attempt to draw an inference about a location parameter of p. Because it is not always easy to identify the relevant population in particular experiment, we begin with some examples. For the sake of specificity, assume that the location parameter of interest is the population median. Example: a machine is supposed to brush the ball bearings that are 1 mm in diameter. To determine if the machine was correctly calibrated, a sample of ball bearings is drawn and the diameter of each ball bearing is measured. For this experiment, an experimental unit is a ball bearing. One measurement or diameter is taken on each experimental unit. Let xi denote the diameter of ball bearing I. Notice that we are distinguishing between experimental units, the objects being measured, all ball bearings, and units of measurement, millimeters. From this example, we can distinguish between experimental units, the objects being measured, all ball bearings, and units of measurement, or millimeters, to determine if the machine was properly calibrated. The normal one sample location problem. The normal one sample location problem, this section we assume that x1 blah 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 xn, not negative normal quantity mu, sigma 2, close quantity. As necessary, we will distinguish between cases in which sigma is known and cases in which sigma is unknown. For samples of any size drawn from a normally distributed population, the sample mean is normally distributed, with mu x is mu and standard deviation sigma x is sigma or root n, where n is the sample size. There are three kinds of the normal sample location problem: A. Point estimation, B. Test hypothesis, and C. Interval estimation. If the true distribution is P equals n quantity mu, sigma 2 close quantity, then the R of the sample median to the sample mean for estimating mu is E quantity P close quantity equals 2P equals 0.64. This statement has the following interpretation. For large samples, using the sample median to estimate a normal population mean is equivalent to randomly discarding approximately 36% of the observation and calculating the sample mean of the remaining 64%. Thus, the sample mean is substantially more efficient than is the sample median at extracting location information from a normal sample. B. Test hypothesis. If sigma is known, then the possible distribution of XA are a normal quantity mu, sigma to closed quantity. Minus tak hingga is less than mu is less than tak hingga. O. If sigma is unknown, then the possible distribution of XA are a normal quantity mu, sigma to closed quantity. Minus tak hingga is less than mu is less than tak hingga, sigma is greater than 0. C. Interval estimation. We will derive confidence intervals from tests. The general one sample location problem. Assume that x1 blah 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 xn not negative p. Since p is not assumed to be symmetric, we must decide which location parameter is of interest because the population mean might not exist. We usually are interested in inferences about the population median m. We assume only that the XA are continuous random variables. There are kind of the general one sample location problem. A. Point estimation. The only natural estimator of the population median m is the sample median x not negative n. B. Test hypothesis. It means like when or mempertimbangkan ujian. C. Interval estimation. It means estimation. The symmetric one sample location problem. Assume that x1 blah 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 xn not negative p. We assume that the XA are continuous random variables with symmetric PDF f let theta denote that center of symmetric. Note in particular that theta is m, the population median. The kind of the symmetric one sample location problem is A. Hypothesis testing. B. Point estimation. C. Interval estimation. A case study from neuropsychology. A case study from neuropsychology, MC Glynn and Gazaniak, investigate awareness of cognitive deficit in patients suffering from Alzheimer's disease, or AD. They recruit 8 pairs of AD patients and their spousal caregivers, or SIGI, and examiner described a neuropsychological task to each subject. Asked the subject to predict how both he or she and his or her spouse would perform on it, and then administered the task. For this experiment, a unit of observation was a matched AD and SIGI pair. 6 measurements were taken on each unit of observation. PPP patient prediction of patient's PS score, patient score PPC, patient prediction of caregiver score, caregiver score PC, caregiver prediction of caregivers CPP, caregiver prediction of patient. Trusted and Zaniak proposed comparative predictive accuracy, or CPA, as a measure of deficit awareness. CPA. Let XA or long CPA the logarithm of the AD deficit unawareness observed for pair I. Well, that's all my presentation. I'm so sorry for my mistake and maybe my voice is not clearly. And then I say wassalamualaikum warahmatullahi wabarakatuh.